8. Until 7 we did yesterday. Now look at question number 8. The demand function of an item is P equals to 30 minus x square upon 10. Everyone be attentive because I'll be doing it fast and I'll not be asking to anyone today. Since I need to finish the syllabus. So I'm just solving and explaining. If you have any doubts, then raise your hands and clarify that. Find the demand and price aligned for maximum revenue. Maximum revenue itself is not asked, but demand and price is asked. So, first of all, we need the revenue function, which I discussed yesterday with you. The revenue function would be equal to P into X. Revenue, there is a price function. So, R is equal to P into X. Now, P price is 30 minus X square upon 10 into X. So, if you open the brackets, 30 into X, 30X, X square into X, X cube upon 10. This is the revenue function. Any confusion in this? Has everyone written this? Raise your hand, is still writing. Now, question asks is demand and price for maximum revenue. So, those conditions are to be fulfilled. Two conditions are there. For maximum revenue, first condition is dr by dx must be equal to 0. Okay, same as maximum and minimum values of y question and minimization of cost. Same procedure. So d upon dx of, in place of r now we will put 30x minus x cube upon 10 equals to 0. Any doubt in this? 30x becomes 30, x cube becomes 3x square upon 10 equals to 0. Don't find the LCM since we are interested in x value only. And remember one more thing. If there is only x square but x is not there, then factorization will not come. Factorization will come when there is x square also and x also. So simply bring this negative on the right side and make it positive. So 30 is equal to 3x square upon 10. Any doubt in this? Minus 3x square upon 10 on the right side becomes positive. Now 10 on the other side will get multiplied. 3 on the other side will get divided. So can I say x square is 30 into 10 divided by 3, that is 100. 30 into 10, 300 divided by 3, that is 100. Now x square is 100, means x is square root of 100, that is plus minus 10. What does x represent in this question? Quantity, demand. And demand cannot be negative. So minus 10 value is not acceptable. It can be only plus 10. Now, x equals to minus 10 is not possible because DECAUSE, demand cannot be negative. Is everyone clear with this? So we will take only x equals to 10. Now we have to prove that the revenue would be maximum. For that second condition, d square r upon dx square must be less than 0. So first we will find d square r upon dx square. What was dr upon dx? 30 minus 3x square upon 10, that we will differentiate again. So d upon dx of 30 minus 3x square upon 10. Okay, this was dr upon dx. Any doubts up till here? Now 30 becomes 0. Minus 3 into 2, minus 6x upon 10. Now here we'll put the value of x and see whether the d square r upon dx square comes negative or not. So at x equals to 10. D square r upon dx square minus 6 into, in place of x we will put 10 upon 10, that is minus 6, which is less than 0. It is coming negative, means the revenue is maximum. Therefore, at x equals to 10, revenue is maximum. Understood this, everyone? Now, are you asked only x in the question? Read the question. Find Demand and price. Demand is X, that we obtained. And price. So price we can find by putting this X in price function. Okay. So how will you find the price? P equals to 30 minus X square upon 10. So 30 minus, what will you put in X? 10. 10 square upon 10. That is 30 minus 10, that is 20. 10 square means 100. 100 divided by 10 is 10. So 30 minus 10, that is 20. Means for maximum revenue, what is the demand? 10. And what is the price? Rupees 20. Did you understand this? Maximum revenue itself is not asking the question. But if maximum revenue is also asked, then in revenue function you will put the value of X. Suppose maximum revenue was also asked. Then in this revenue function we would have put X equals to 10. 30 into 10? 300. 10 cube? 1000. 1000 divided by 10? 100. 300 minus 100. What would be the maximum revenue? 200. If you can cross check. What is the price? Demand? So 20 into 10? 200. The maximum revenue would be 200 rupees. Did you understand this portion, everyone? But maximum revenue is not asked. If asked, then we would have substituted. Okay. What is asked is read on this. Demand is 10 units and price is 20 rupees for maximum revenue. Any confusion in this? Now, look at question number 9. In a market, the demand law of rice is on X equals to 3 in bracket 60 minus P. Find the demand for maximum revenue and also find the price and revenue for that demand. Now everything is asked. Demand is also asked, that is X. Price is also asked and revenue is also asked. Is everyone clear with it? Very first of all, this X demand function which is given, we have to express it in this order. Where a right side you always get and left side you always get D. Because the whole question is to be solved in terms of X. So, can I bring 3 on the left side, it will get divided? Any doubts in this? Now bring minus P on the left side and X on the right side. So do we get in this order or not? Okay, whatever equation and revenue function is given to you, always convert it where price P comes on the left side and demand X comes on the right side. Then start solving it. Any doubts in this? Now, revenue R is equal to P into X. P is 60 minus X upon 3 into X. If you open the bracket, 60 into X, 6X. 60X. Then X into X, X square upon 3. Is everyone clear with this? Raise your hand who is still writing up till here. Now, for maximum revenue, dr upon dx must be equal to 0. So, d upon dx of, in place of r, 60x minus x square upon 3 must be equal to 0. Now, 60x will become 60. X square will become 2x upon 3 must be equal to 0. Okay, now here only x, so no need of factorization as such. Bring this minus on the right side, it becomes plus 2x upon 3. Now 3 on the other side will get multiplied. 2 on the other side will get divided. So what is the value of x? 60 into 3 divided by 2, that is 90. Only one value of x means it's quite obvious that at that value itself, the revenue is maximum. But we have to prove. We have to prove that your d square r upon dx square comes less than 0. Is everyone clear with it? You always have to prove that. So now we find d square r upon dx square. What was d r upon dx? This we have to differentiate again. So d upon dx of 60 minus 2x upon 3. 60 becomes 0. Minus 2x upon 3 becomes minus 2 by 3. It already becomes negative. And there is no x. Means even if x is 90, minus 2 by 3 is going to remain minus 2 by 3 only. So we'll say at x equals to 90 also, d square r upon dx square is minus 2 by 3, which is less than, understood this? Therefore, at x equals to 90, since it comes negative, revenue is maximum. Anyone having any doubt in it? Now what all is asked in the question? X demand we obtain. What all is asked? Price and then revenue also. So how would we find price? In this equation we'll put the value of x as 90. Has everyone completed up till here? Therefore P is equal to 60 minus x by 3. 60 minus what will we put in x? 90. What is 90 divided by 3? 30. So 60 minus 30 is 30. Did you understand this, everyone? Demand is obtained, price is obtained. What else is asked? Revenue is also asked. So revenue R. What is the function of R? 60x minus x square upon 3. What will you again put in x? 90. Minus 90 square upon 3. What is 60 into 90? 5400. 90 square is 8100 divided by 3, 2700. And 5400 minus 2700 is 2700. This you can cross check. What is the price? 30. What is the demand? 90. So price into demand, 30 into 90, 2700. The maximum revenue would be 2700. Price into demand. Did you understand this, everyone? You mentioned this. For maximum revenue, demand is 90 units and price is rupees 30. Okay. So also maximum revenue is rupees 2700. So all of you are clear with these revenue questions? Okay. Now there is only one illustration in the textbook for revenue. So you take question 10 also as your homework. Mark question 10 as your homework. At least 2 you must practice. And see here, 10 is exactly similar to 8. If the demand function is P equals to 75 like here, minus x square upon 3500, then at which demand the revenue is maximum, means x is asked. And thereafter also find the price for maximum revenue, P is asked. So it is exactly similar to 8th question. Okay, mark it as your homework. Now we take up with questions based on profit, minimization cost we did yesterday, maximization of revenue is done. Now maximization of profit. What did I make you write yesterday for maximization of profit? How would you find the profit first of all? R minus C. Okay, max profit would be obtained as revenue minus cost. And then conditions are same like revenue. First condition, dp upon dx must be equal to 0. Second condition, d square p upon dx square must be negative. Then the profit will be maximum. So look at page 199, section F, question number 4. In profit, 3 questions I'll do on the board. And only one illustration is there again for profit also. So 2 exercises you'll take in homework. 3 in class and 3 in homework. That way. Question 4. A producer produces X units at a net cost. Means C equals to 200X plus 15X square. There's a cost function. Any doubt in this? The demand function is around P equals to this small p, okay, price function. 1200 minus 10x. First of all, find the profit function. So we discussed profit P equals to R minus C. For that first we require revenue function also. That would be P into X. Thereafter, how many units should be produced for maximum profit? So that maximization of profit condition is to be fulfilled. First of all, write down revenue R is equal to P into X. P is 1200 minus 10x into X. So 1200x minus 10x square. Any confusion in this? Now profit can be obtained, profit function. capital P. That would be R minus C. Now what is R? 1200x minus 10x squared minus, what is C? 200x plus 15x squared. If you open the brackets, 1200x minus 10x squared minus 200x and minus into plus minus 15x squared. Any confusions up till here? We are first finding the profit function. Okay, revenue minus cost. 1200x minus 200x, 1000x, minus 10x square minus 15x square minus 25x. This is the profit function. 1000x minus 25x square. Any doubt in this? Now the conditions. How do we start like we used to start for revenue? For maximum profit. Yes, what will you say for maximum profit? dt upon dx must be equal to 0. That is d upon dx of a profit function is 1000x minus 25x square must be equal to 0. Now 1000x becomes 1000 minus 25 into 2 minus 50x must be equal to 0. Minus 50x on the right side will become positive and 50 will get divided. So x is 20. Single value of x is obtained. Means automatically your d square p upon dx square will come negative at that value. Is everyone clear with it? Now you have to fulfill the condition that at this value of x the profit is maximum. So what will you find for that? d square p upon dx square. That is d upon dx of. Now what was dt upon dx? 1000 minus 50x. This is to be differentiated again. 1000 becomes 0 minus 50x becomes. See, automatically it comes negative or not? Even at x equals to 20, it's going to remain minus 50 only. At x equals to 20, d square p upon dx square is minus 50, which is less than 0. Therefore, at x equals to 20, profit is maximum. Now this much is only asked. What is asked in the question? Find the profit function that we obtained 1000x minus 25x square. And how many units should be produced for maximum profit? 20 units should be produced for maximum profit. Maximum profit is not asked. What you would have done if maximum profit was also asked? Substituted which function? 1000x minus 25x square. This one. Profit function. If maximum profit was also asked, then 1000 into 20, 20,000. 20 square, 400 into 25, 10,000. 20,000 minus 10,000, 10,000. The maximum profit would be rupees 10,000. But anyway, that is not asked. Did you understand it? Two things what are asked, we'll write it again. Thus, profit function is, okay, two things what are asked, we'll write it again. Thus, profit function is 1000x minus 25x square and, okay, this is the profit function, 1000x minus 25x square, and profit will be maximum when 20 units are produced. Did you understand this? When 20 units are produced. Now look at question 5. The selling price of a refrigerator as determined by the company is rupees 10,000. So what is 10,000? P. Selling price means P is 10,000. The total cost of the production for X refrigerator is spread on C equals to 0.1 X square plus 9,000X plus 100. How many refrigerators should be produced or manufactured for maximum profit? Again, only X is asked. Maximum profit itself is not asked. Is everyone clear with it? First of all, what will we find? Revenue function. Let on revenue R. How will we find that? P into X. So simply 10,000X. Any doubt in this? What next will we find? Profit function. Capital P. That is equal to R minus C. So R is 10,000x minus C is in bracket 0.1 x square plus 9,000x plus 100. So if you open the brackets, 10,000x minus 0.1x square minus 9,000x minus 100. Now 10,000x minus 9,000x, 1,000x minus 0.1x square minus 100. Any confusion in this? So profit function is obtained. Now what next? For maximum profits, what is the first condition? dp upon dx must be equal to 0. So d upon dx of in profit will substitute 1000x minus 0.1x square minus 100 must be equal to 0. Any confusion up till here? Now 1000x will become 1000. 0.1 into 2, 0.2x and 100 becomes 0. Is everyone clear with this? Raise your hand if it is not clear up till here. Minus 0.2x on the right side will become plus, and 0.2 on the left side will get divided. Means x is equal to 5,000. Only single value means automatically your d square p upon dx square will come negative. Okay, so now we will find d square p upon dx square. What was dp upon dx? 1000 minus 0.2x. This we have to differentiate again. Okay. So d upon dx of 1000 minus 0.2x. 1000 becomes 0 and minus 0.2x becomes minus 0.2. See, automatically it will get negative or not? Means at any value of x this is going to remain same. So even at x equals to 5000, d square p upon dx square is minus 0.2, which is less than 0. Therefore at x equals to 5000, profit is maximum. That is the only thing is asked. Are you asked maximum profit? No. At what units the profit would be maximum? 5000 units. What if maximum profit was also asked? You would substitute 5000. In which function? Profit function here. 1000 into 5000. So 50 lakhs. 1000 into 5000, 50 lakhs. And then 5000 square, 25 lakhs. 50 lakhs minus 25 lakhs into this is 2,50,000. So 47,50,000 minus 900. 47,49,900 would be the maximum profit if asked. Is everyone clear with this? Anyone having any doubt into this? Now as I said, 3 questions are to end. 3 you'll take in homework. 1 illustration is there and 2 from exercise. So this question 6 you take in homework because here also only x is asked. Look at it, I'm reading it. A toy is sold at 20 rupees. It is exactly similar to this. What is this 20? P price. Total cost of producing such toys is 1000 plus 16.5x plus 0.001x square. So what would be your revenue function? 20x, and then you can do 20x minus the cost function. And then again it is asked how many toys should be produced for maximum profit. So again only value of x is asked. Exactly similar. This to take it home. I am solving section E's question 11 where profit is also asked. Look at it. Section E's question 11. The profit function of a producer is 40x plus, and a profit function directly given. Like these 2 questions we found the profit R minus C. You can see in question 11 profit function is directly given. 40x plus 10,000 minus 0.1x square. At what production? First of all x is asked. At what production is the profit maximum? Then also find this maximum profit. So here we have to put this value of x in profit function also. Did you understand this? But profit function is directly given. So let us solve this. Page 199, section E, question 11. Yes. The term profit function capital P is given as 40x plus 10,000 minus 0.1x square. Okay. Directly we have to start with for maximum profit. Yes, what will we do? dp upon dx must be equal to 0. So d upon dx of 40x plus 10,000 minus 0.1x square must be equal to 0. Clear with this, everyone? Now 40x becomes 40, 10,000 becomes 0, and 0.1 into 2 minus 0.2x equals to 0. Clear with this, everyone? Now minus 0.2x on the right side becomes plus, and 0.2 on the left side gets divided. 40 divided by 0.2, that is 200. Is everyone clear with it?
Yes.
Single value of x means automatically d square p by d upon x dx square is going to come negative. D square p upon dx square equals to d upon dx of. Now, first of all, what was dp upon dx? 40 minus 0.2x. This we have to differentiate again. Now 40 becomes 0, minus 0.2x becomes minus 0.2. As I said, automatically it comes negative. Even at x equals to 200, it's going to remain minus 0.2. Even at x equals to 200, d square p upon dx square will be minus 0.2, which is less than 0. Therefore, at x equals to 200, profit is maximum. Did all of you understand this? Any doubts in it? Now, we are also asked maximum profit means this x we have to put in the profit function. So profit P would be equal to 40x plus 10,000 minus 0.1x square. 40 in place of x we will put 200 plus 10,000 minus 0.1, again in place of x we will put 200 square. 40 into 200, 8,000 plus 10,000 minus 0.1 into 40,000, 8,000 plus 10,000 minus 4,000, 14,000. Okay, the maximum profit would be 14,000. Did everyone understand this? So how to find maximum profit is also clear. Thus, profit will be maximum at 200 units and maximum profit is rupees 14,000. Okay, so 3 questions of profit are done in the class, and as I said, only 1 illustration is there of profit in textbook. So 2 questions you'll take in homework. Take this question 12 in homework. There also only x is asked. That final substitution is not to be done. Only units are asked. Okay, so which all questions from exercise are your homework? Question 10 of E, 12 of E and 6 of F. But they are several ones. Okay. 3 exercises are given in homework. So 2 illustrations I do in the class. Last concept in the chapter. In the summary, give the heading Elasticity of Demand. Now listen everyone. Formula, I am writing it and also explaining how is it derived. Elasticity of demand is equal to minus P upon X into dx upon dP. Minus P means price upon X is demand, units. Into d of X upon d of P means derivative of demand with respect to price. Now, raise your hand. What formula or concept did you study for elasticity of demand in economics? Okay, let's not waste time. Percentage change in demand upon percentage change in price. Now, demand I am writing as X, okay? Can I say percentage change in demand means change in demand upon original or first demand into 100 and change in price upon original price or first price into 100. Now this 100 gets cancelled. So change in demand upon original demand. Can I multiply it with reciprocal? Price upon change in price. Now, can I shift these positions? Means can I write it as P upon X into delta X upon delta B? Or change in X upon change in B? P upon X. And what is change in X upon change in B? Derivative of X with respect to B. So this is how this formula is derived. What does dx upon dt, like what does dy upon dx indicate? Change in y due to change in x. So what does dx upon dp indicate? Change in demand due to change in price. Why we put negative? Because there is inverse relation between price and demand. So your answer will always come negative. To eliminate the negative, for convenience we take the answer as positive. To eliminate the negative sign, further we put minus. So minus minus will get cancelled. Is everyone clear with this? So only this much formula will remember. Okay, what is the formula of elasticity of demand? If you find it using calculus, minus P upon X into dx upon dt. Any confusions with this? Look at illustration. There are no exercise questions on elasticity. There are two illustrations, so both the illustrations I am taking up in the class. Illustration 30. And illustration 30 I take it with one extra alternative also. Otherwise you will not understand illustration 31. Okay. Illustration 30 on page number 189. Yes, listen carefully. The demand function of a commodity is x equals to 50 minus 4p. Find elasticity of demand when circle p equals to 5 and interpret it. Now listen carefully. We have to find elasticity of demand at price equals to 5. Means finally whatever equation of elasticity of demand we get, in that p will be substituted as 5. So on the right side we always require p, which is already there. Suppose it was asked, find elasticity of demand when demand is 20 units. Then what is 20? X. Not p, it is x. Means finally when we find elasticity of demand, we will have to substitute x equals to 20. We will have to change this equation, because then on the right side we require x. Then you would do 4p equals to 50 minus x, and p would be 50 divided by 4 minus x divided by 4. That extra alternative I will solve after this, so that you understand in any terms the final question is asked how to do it. The right side should be in terms of final question. What is the final question? P equals to 5. So on the right side you must have p. Then only you can substitute that. If x is given, then on the right side we must have x. This basic information is clear. If elasticity is asked at price p, then on the right side we must have p. If elasticity is asked at demand x, then on the right side we must have x. One more time. If elasticity is asked for a price, then right side we must have price. And if elasticity is asked for a demand x, then right side we must have x. Okay, write it down in the summary as a note. If elasticity of demand is asked at p, then right side of the equation must have p. Okay, below that, if elasticity of demand is asked at x, then right side of the equation must have x. Okay, in that situation you would change the equation. Did you understand it? And we presently will solve it as it is, because p equals to 5 is given and we already have p on the right side. Understood this? So straight away we will apply this formula, but first we require dx upon dt. And on dx upon dt, equals to d upon dp of 50 minus 4p. Any doubt in this? Now 50 becomes 0 and minus 4p becomes minus 4. Now we can apply the formula of elasticity. Therefore, elasticity of demand is equal to minus p upon x into dx upon dp. Keep in mind, because finally p is given on the right side, everything should be expressed in terms of p. So minus p, keep it as it is. In x, we will substitute 50 minus 4p. So does everything become in terms of p or not? If finally x is given, then x you would keep as it is, and in p you would substitute the equation and make it in terms of x. Understood this? Into, what is dx upon dp? Minus 4. This minus will always get cancelled. That is the reason we are taking minus sign. Okay, this minus will always get cancelled. That is the reason we are taking minus sign, as I said. Because of inverse relationship, elasticity is always negative, but for convenience we take it as positive. What remains? Can I say 4p upon 50 minus 4p? 4 into p. Okay, 4 into p, 4p upon 50 minus 4p. Now can we substitute that p5 and find the elasticity or not? At p equals to 5, elasticity of demand is equal to 4. In place of p now we will put 5 upon 50 minus 4, again in place of p 5. 4 into 5, 20. 50 minus 4 into 5, 20. So 20 upon 30, 0.67. Did you understand this? What does it mean? Percentage change in demand upon percentage change in price is 0.67. Means if price changes by 1%, demand will change by 0.67%, but in opposite direction. If price increases by 1%, demand will decrease by 0.67%. If price decreases by 1%, demand will increase by 0.67%. Okay? 0.67 is less than 1. So in economics you should have studied inelastic demand. Means effect of price on demand is less. When price is changing by 1%, demand is changing less than 1%, 0.67, inelastic demand. Okay, so right on below that does. If price changes by 1%, then demand will change by 0.67% in bracket in opposite direction. Means if price increases, demand will decrease. If price decreases, demand will increase. Did you understand this? Now listen everyone. Suppose in this question you are asked, same illustration 30. Like it is given, find elasticity at t equals to 5. Find elasticity of demand in illustration 30. Find elasticity of demand. In notebook itself write it. Extra question. Find elasticity of demand in illustration 30 at x equals to, let us say 10 units. Suppose. Okay, just for example, 10 units. Earlier we obtained at p, so I told you right side must be in terms of p. Now we have obtained at x, so right side must be in terms of x. Now here you are given x equals to 50 minus 4p, but what do we need on the right side? X. Bring 4p on the left side and x on the right side. Any doubt in this? Now does the right side become in terms of x or not? But we require only p. So can I say 50 by 4 minus x by 4? 50 divided by 4, 12.5 minus x upon. So now do we get right side in terms of x or not? Everyone is clear what is to be done? Okay. Now we will apply the formula. First we have to find dx upon dp, but we cannot find that because we have p. Can we find dp upon dx or not? We'll find that and reverse it. We'll find dp upon dx. D upon dx of 12.5 minus x upon 4. 12.5 becomes 0. Minus x upon 4 becomes minus 1 upon 4. Now, if dp upon dx is minus 1 upon 4, then reverse it. Can I say dx upon dp will be minus 4? So, did we get dx by dp required for the formula or not? Any confusion in this? Now we apply the formula. Therefore, elasticity of demand is equal to minus p upon x into dx upon dp. Now what did I tell you? Since elasticity is asked at x equals to 10, we require this in terms of x. So x will keep it as it is. In p we will substitute 12.5 minus x upon 4 minus bracket 12.5 minus x upon 4 upon x into, this is p. Is everyone clear with this? Upon x. What is dx upon dp? Minus 4. So minus gets cancelled. Remaining keep it as it is. Don't simplify. 12.5 minus x upon 4 whole upon x into, now we are asked elasticity of demand at x equals to 10 units. So therefore, at x equals to 10, elasticity of demand is equal to 12.5 minus, what will I put in x here? 10. Divide by 4. Whole upon 10 into 4. Can I say 12.5 minus 2.5 upon 10 into 4? What is 12.5 minus 2.5? 10 upon 10 into 4, that is 4. Did you understand this? So if price changes by 1%, demand will change by 4% in opposite direction. But why I have done this? So that you understand the main point. If elasticity is finally asked at p equals to 5, then right side we require p. If elasticity is asked at x equals to 10, then right side we require x. In that situation, we cannot get dx upon dp, but we get dp upon dx. So whatever dp upon dx you get, you will reverse it. Did you understand this? Now you will be able to understand illustration 31, because that is opposite line. Look at it. Illustration 31. Last question. Page 19. Be attentive. The demand function of a commodity is that on p equals to 12 minus root x. Find elasticity of demand when cancel price, make it demand is 9 units, because price cannot be 9 units, it should be rupees 9. So make it demand is 9 units and below demand write x. Now what is this 9? What is this 9? X. So our right side should be in terms of x. It's already in terms of x. Do we need to change it? No. Understood that basic point? Any confusions? So we can get dp upon dx. That is d upon dx of 12 minus, can I write x raised to 1 by 2? Root x means x raised to 1 by 2. 12 becomes 0. Minus 1 by 2 x raised to 1 by 2 minus 1 minus 1 by 2 x raised to 2 into 1 is 2. 1 minus 2 minus 1 by 2. That will come in the denominator. So minus 1 upon 2 root x. Any doubts in this? But this is dp upon dx. And in the formula we need dx upon dp. So reverse it. What will be dx upon dp? Minus 2 root x. Any confusion in this? Now we can apply the formula. Therefore, elasticity of demand is equal to minus p upon x into dx upon dp. Now, since finally x is given, everything on the right side must be in terms of x. So x will keep it as it is. We will put the value in terms of p. What will we put in p? Minus in bracket 12 minus root x upon x into, what is x upon dp? Minus 2 root x. Minus gets answer. Remaining keep it as it is. Are you all clear with it? Now here in x we have to substitute. Now here in x we have to substitute 9. At x equals to 9, elasticity of demand is equal to 12 minus root of 9 upon 9 into 2 root 9. Wherever there is x, we substitute 9. What is root of 9? 3. So 12 minus 3 upon 9 into 2, and root of 9 is again 3. 12 minus 3 is 9 divided by 9 into 6, that is 6. Means if price changes by 1%, demand will change by 6%. Did you understand this? And thus, if price changes by 1%, then demand will change by 6% in bracket in opposite direction. Now be attentive. I want that you try this illustration in homework with, like here you are given 9 demand units, you try it with price. Just initial thing, note it down. See if P is 12 minus root x. Now if price is given, then right side we require P. What will you do? Root x equals to 12 minus P. What will you do to cancel the root? After that the procedure will remain same. So as an extra question, write down solve illustration 31. Elasticity is required at rupees 16. Okay, so finally next we'll substitute 16. Any confusion in this? All are clear with it? So this question is your homework, and how many from exercise? 3. And illustration 34 and 35. I told you only one illustration is there on revenue and one on profit. So illustration 34 and 35. Look at page number 196. Let us mark the exercise answers first. Page 196, section D. Define differentiation. You can even write what I made you write in the notebook. Mention as notebook. It's perfectly fine. I made you write in the notebook. It is a technique of finding change in y due to change in x. That is the meaning of differentiation. Okay. Question 4. State the rule for derivative of product of two functions of x. Remember u into v. So you already know that. Okay, v square into du by dx plus u square into dv by dx. How will be the first order derivative of a function at x equals to a if function is decreasing? If function is decreasing, I made you write. Decreasing means f dash x will be negative. Increasing function f dash x is positive. So write down here, first order derivative will be negative. How will be the second order derivative? D square y by dx square of a function at x equals to a. Function is unlike maximum. Maximum then again less than 0. Write down negative. How will be the second order derivative for maximum function? Negative, and for minimum it will be positive. What are stationary points of a function? If you remember, I discussed with you where dy by dx equals to 0. The points where dy by dx equals to 0. Still you mark it as page 184. And look at page 184. Do you find before the method in dark letters stationary points is written? Underline that sentence. The points where maximum or minimum values occur are known as stationary points. In next sentence, the necessary condition to obtain a stationary value is dy by dx equals to 0. Mark this important, okay? Third question. What is marginal revenue? In economics itself we have studied change in revenue due to change in one unit. But page number 187. Look at page 187 and underline that the change in revenue due to small change in demand is called marginal revenue. Same page also underline that marginal cost. The change in cost due to small change in production is called marginal cost. Okay, that was question 9. So both of them mark it as page 187.